This lesson is a portion of 3.2 and 3.3. We're changing up the way the book's teaching it a little bit, so we're going to be tackling a little bit of both of these chapters. Specifically, we're going to be looking at the interior angles of polygons. The goal is to understand how to calculate the sum of interior angles of any polygon. All right, so let's start off with what we basically discovered in class. We started off with triangles, and we did a little activity where we took the corners of the triangles and basically cut them off. And then we line them up with each other. And so if I take these and rotate them, what we discovered was that if you line them all up and rotated them like I'm doing here, that they always had the same result. And then everybody in class had a different triangle. But despite that, all of these turned out to add up to 180 degrees. Now, assume I just did a slightly better job there, but notice how this line, that this angle plus this last angle, all ended up being 180 degrees. So one of the key understandings is that interior angle measures of a triangle, the sum of those measures is always 180 degrees. And so that was our basic understanding, that angle X, angle Y, angle Z, all added together will always equal 180. So we can do problems like this one. Find the missing interior angle measure. So here I've got three angles, one of them's missing. So I would do something like this. Oops, gotta get the pen. 32 degrees plus 48 degrees plus our unknown X degrees. It's part of a triangle, so it must equal 180. So if I simplify and solve this, I'm gonna get 80 plus X equals 180. Subtract 80 from both sides, and we get X equals 100. So this last corner must have been a 100-degree angle. All right, so then we had a discussion and took this much further. We looked at four-sided objects, five-sided objects, six, and so on, and we discovered this, that for four-sided, always turns out that the angles add up to 360 degrees. For five-sided, it was 540 degrees. For six-sided, 720. Okay, and we could go on here further. And so one way we did this, some groups did, was they just looked at doing the same thing. They cut off the corners. Oops, let me pick a different color here. They, cut off the corners here, put them together, and they formed a 360-degree full turn. 540. You got 360 plus an extra 180. All right, but another way to look at this is to think of what we learned about with triangles, that triangles always add up to 180 degrees. So other groups tackled it like this. They saw that I could take this quadrilateral, slice it from vertex to vertex right here. Oops, that's horrible. Let's do that over. And get two triangles. So these three angles add up to 180, and then these three angles add up to 180. So it's basically just 180 plus 180, which got us the 360. I could do the same thing with the five-sided shape. I could start at, let's say, this vertex, cut off the top to create one triangle, go from that same vertex and cut through here to this spot, and then I get two more triangles. So one triangle plus two triangles plus three triangles, it's three triangles with 180 degrees apiece, and that's where the 540 comes from. And same thing if we continue with this pattern. Pick a vertex, start cutting triangles. There's 1, 2, 3, and 4. 2, 3, 4. So we get 4 times 180, and that's where we got the 720 from. So when we took all this information and looked at it as a class, we found these different patterns. So if we first listed the number of sides that our polygon had, we noticed that, of course, a three-sided shape, it forms a single triangle. But a quadrilateral, a four-sided shape, could be split into two triangles, five-sided into three, and so on and so forth. And so that if each triangle was 180 degrees, well, it was just 180 for each triangle. So two triangles, 180 plus 180. Three triangles, 540. Four triangles, 720. So on and so forth. So what we developed was this pattern. So let's say we call the number of sides n. N number of sides, any shape, 10, 100, whatever. That if you look here, the number of triangles in that shape is always 2 less than the number of sides. 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 3 is 3. 5 minus 2 is 3. 8 minus 2 is 6, so on and so forth. So we could describe the number of triangles inside a shape as the number of sides minus 2. And if this is the number of triangles in the shape, then all I have to do is multiply that by 180, and that gives me the sum of the interior angles. So we do 180 minus the number of triangles, and minus 2. And so what we developed was this formula. The sum of the measures of interior angles of an n-sided polygon, so for any number of sides, S is the sum. It's always equal to 180 degrees times the number of sides minus 2, because the number of sides minus 2 gives us the number of triangles. All right, so once again, we can use that to our advantage for a problem like this last one. Let's say I've got this quadrilateral. All right, I have x, 115, 80, and 90. All right, so first I need to know in total how much this is. Now, even though we saw it on our chart, let's use the formula. So the sum of all the angles of a four-sided shape is going to be 180 degrees times the number of sides minus 2. So parentheses first, 4 minus 2 is 2. So 180 times 2 is 360. All right, so now I can write a formula, or an equation. X plus 115 degrees plus 80 plus, and of course this is 90, equals 360. So all this added together, we're going to get x plus, let's see, 80 plus 90, that's 170, 285 equals 360. Then of course subtract 285 from both sides. And we get x equals, let's see, 15, 75 degrees. All right, so this angle here was a 75-degree angle. All right, so we had to figure out the number of the sum of the interior angles first using our formula, and then we used that to create an equation to find that missing number of degrees x. All right, so this is interior angles. This is how you figure them out for any polygon, not just triangles, but for any shape.